Hi guys, this is Gabriel here for another walkthrough on the task 2 of artificial intelligence, and this is going to be like a 10 to 15 minutes video. I'll be like getting you with all kinds of how to get through these software that is being provided in the task and complete your task in a limited period of time. Well, I did succeed, and I would like to share this small video as a token of as a success, and I want to share my success with I would like to enjoy you with a Latvian beer, which is like Seshu brewed something guys alus. So Priyanka, cheers. So well, it's a pretty good stuff. Okay, so let's get into the topics. So thanks to BB Software. Okay, I'm sorry. Too much of passwords, I can't remember them very bad. I'm very poor and I can't remember it. And so, the deal is, well, I'm Gabriel. My short introduction is I'm Gabriel, studying business informatics from Riga Technical University of Latvia. And so here is a walkthrough that I would like to. My subject is artificial intelligence and for business. Sorry for the poor coverage and guidelines, and so here we go with the lab work of search. Start download, open folder, extract them. Cool. So how I'm going to get through this is the program. You have to install the latest version of Oracle Java JDK, and so you can run the batch file. So to get your jar file running good, okay, so cool. This seems to be a quite complex graph, in fact, but no need. I can get to, actually there are three sort of algorithms you have to solve. The first one would be a breadth first search. The second one would be a depth first search, which is like a kind of iteration, depth driven deep search. And the third one would be like it's a greedy algorithm implementation. And the second part of this exercise would be like you will be asked to run the task that already exists on the web. So sorry, in the application. So now I'm going to, what you have to know is like what is DFS, depth first search. Okay, depth first search algorithm. So this is the depth first search algorithm. You must just see this particular video which I referred was more helpful for me. And the depth first search is something like it's a kind of I would suggest like it's like a stack where it's like the first element you put it's like getting the last one first up. Well, okay, I'll show you something. I'm sorry if I just I don't want to provide false statements, So in this case, you see the stack, and in this case, the A is the first node which I'm visiting, so I'm pushing it into the stack. And next, I'm going to go to the next successor, which is going to be the B, as per the alphabetic. It's not like alphabetic or something like B, and you're pushing B into the stack. And note this point: when you push B into the stack, you don't have any successor. So in this case, you can pop the B outside the stack. You may see that. You can pop the B outside the stack. You can see there is no successor. It comes back to A only, so that's an option. So you pop out B outside the stack. And next what you do is go to the next successor, which is S. The S is like, you know, I'll increase the speed. Probably this would help you. 1.5. Yeah. So next you visit S, and then you push it into the stack. And when you check the next successor, it would be C. So you're pushing C into the stack, and now you're checking for the C successor, which is going to be D, E, and F. But now for you're pushing D, and you can see the D has no successor, so you can pop it out. So you pop D outside the stack, and you come back to C, and you go again visit the new node E. So you see, you go to the new node E, and you push it into E, and now E is visited. Now you have to see the successor for E, and you find H, and you push it into the stack. And for H, you have any successor? Check it. G, push it into the stack. Now you're good. And for G, check any successor. You have F. Now you're good to go. You can pop every element. Now everything is visited. So you can see A, B, S, C, D, E, F, E, H, G, F, H. Okay, it's like that. You pop it out, and you get an order. This is depth first search. You go in depth. But whereas if you see breadth first search, it's something like a queue. So for in this case, you see, it's a queue. So in this case, I'll just clear your concepts more, speed to 2. Okay, now you see, the first thing I push A into the queue. The deal is all the thing cannot be visited, you know, like if now I'm visiting A and then I'm going to visit B. It's like states. You cover like the states. A, then you go for B, and you mark it as visited, and then S. Good. And now next is you can pop the B out. That's like DQB, and then you come to S, and you can DQ S, and you can see the S has C and G. So you pop in NQC and G, and for C, the top of the queue, which shows you what is the successor, is D. So you can pop out C, and you can insert F, D, E, and F. Good. So we are done, and now at this point you have to go and see the top of the queue, which is G. You have to pop it out and see the next element, which is going to be the H. That's it. That's the case. Then you can pop each element out and frame your thing and empty the queue, and you can attain the goal state. It's like you can choose your own goal state, and you can make a way how you search. How does the search algorithm is implemented to attain the goal state in breadth first search? And this is an idea behind this breadth first search. And next is a greedy algorithm. So in this case, the same concept, but in case of greedy algorithm, you have some kind of weights. Like, you know, for A you have 10, and for the B in the graph you saw before, in the same graph you may have weights like for A 10, B 5, C 6, and D 7, and something like that. So in that case, you can you search based on weights. You like instead like to achieve a shortest goal. To attain the shortest goal, like for instance, you have to reach a particular goal state in the shortest period of time with the shortest cost. Weights are cost. You can use the term weights are cost. You can use the particular part to reach your goal state in a very short period. So this is the concept behind breadth first search and depth first search and the greedy algorithm, which is going to be implemented in this tool which is provided by our university. So let's get started with this. So this is an algorithm. You see the graph, first out of 3 algorithm, breadth first search. You can see the 1 is open, so I'm going to give 1 open, and now you see the next closest elements near to the it's like the successor for 1 for a breadth first search based on the states is going to be like 2, 6. You see 2, 6, 3, 2, 6, and 3. Check it. Yeah, good. I change the list. You see the 2. We have to put the 6. Next iteration. Good. We are in iteration 2. And next, what we are going to do, we have this the first. So as I mentioned, breadth first search, you use queues. So in this case, the top of the queue is 2, and you're going to open 2 into the list. 2. Insert into the list of it. For the 2, you can see 4, 7, 4, and 7. So insert 4 and 7. Change the list. And you can 4 and 7. Yeah, next iteration. Oh, okay. Sorry. The 7 should go up. Next iteration. Cool. In this case, you see the 6 is in the top of the queue. So here's the 6. Open and close it. And let's see the 6 which has 4 which is already visited, 1 which is already visited, and 7 is new, but 7 is also visited in the 2. You can see here the open and the closed. You see? So in this case, it's like we have 10 that can be visited, and we can insert 10 into the queue. Change the list to 10. Next iteration. Now you can see the next is 3. The 3 is open, and you close it with 3, and you can see 5, and 5 is not open. So change this. Next iteration, and so you go for again 7, 7. And you can go for insert into list open, which is 7 in the case. You have 5, which is already visited, and you have 6, you have already visited. 2 is already visited. So no need, just go change list. Next iteration, and you can go for 4, open list that is 4, and close it. Close it to 4, and now we can see the 4 has 6 as the successor, but it is visited. So just change list. Next iteration, and you can go to exclude from the list open, which is 10 and 5. You insert 10, which is a goal state. You see, 10 is a goal state. So we are just close it to 10. Yay, we did it! Congratulations, you provided the correct solution. Continue to the next algorithm. So we did a great job. So that's how the mystery for breadth first search have been solved. And now I'll provide you with a screenshot for the sample. And it's going to be, and my friend is nearby with me currently, and he's watching my videos, in fact. Okay, just a minute. Okay, you know, a lot of rules and regulations process. Well, I'm just showing you videos like how to get things done, not encouraging you to copy or something, you know. I'm just helping you out to understand the concepts as clear as possible and solve the problems. So this is first rock. Okay, cool. Now we are going to the next algorithm, you know. The next is iterative search. So here is my depth 2 iteration search. In case of iteration search, the difference is that between the depth first search and the iteration search is like you go around like a couple of iterations. Well, I consider iteration is time consuming while all the states have been covered in this iteration search, and most of them doesn't consider this as an effective algorithm, but still you can use it in your research or kind of thing. So in this case you can let's get started. So in depth first search it's like 1, you see, you first put 1 2 and 3 2 6 3, okay, and rearrange them properly like 2 and 6 and 3. Next iteration, you put 2, open from the open you put 2, and close that open into to close. So you use 2. Just have a small beer for the first success we had in the first task, the first breakfast search. Okay, so next is like 2 you do insert into list open, which is 2 for 2 we have 4 7, 4 and 7, 4 7, change the list. Okay, this is something getting fishy over now. I said iterative search, so for 2 I'm just covering a single state 1, state 2, state 3. So for the first state I do an iterative search, the second next iteration the next state, the next iteration the third. So in this case I'm just going to do a change list. I cannot use this. For the first state is covered, change list. Next iteration 6. So dumb, you know, this one really looks so dumb, but it's solvable. And for 6, so I change the list. Next iteration, similarly you have to put 3, change list. Next iteration. Cool. Now we are into depth. Iteration 5. So change list. Okay, I'm sorry. Okay, so I'm putting 1. What? Just change list. Okay, your answer is not correct. Just a minute. So in this case I press a failure and we are going to the depth 3, iteration 6, and in this case we'll be covering the next states, you know. And so in this case you see the next state is like 2 for 1, you close this 1, and for 2 3 6 7. Okay, now 2 3 and 6, change list. So 2 6 should go up. Okay, dude, Priyaka. Cheers. This is for my friend. And next is change list and go to 2. From open put it to closed. It is like 2. Now you can see the 2 has 7 4. The 7 and 4 as in successor. So you put 7 4, change list, and you can it's like next iteration. Now the so push up next. Okay, just a moment. Okay, 2 is like 4 and okay, first is 7, I think so. Just a moment. So in this case I've sorted the list, and now it's going to be depth 3 iteration 8. So in this case let me see, putting 7 into the open and I'm putting 7 into the closed. And now for 7 have 5 as, but 5 is not yet visited, so in this case 7 I'm putting 5, 8, no, 7, 2, 5, so just 5. Next iteration, no, I have to sort it, so push up. Next iteration, and you can see depth 3 iteration 9. Now I'm putting 5 into the stack and close 5, and for 5 I have 7, 8 and 9, which is here. 7, 8, 9, 7, 8 and 9, and you can see 7 is already closed, so it's visited, and 8 and 9 is the only thing I can put. Okay, your answer is not correct. Why? So in this case 5 I consider this is state, 7 is visited, 8 is, and 9 maybe they are another states, I think so. So I'm just change list. Next iteration 4, this seems to be small or complex graph in fact, so put 4 insert in the list, open. It's like for 4 you have 6, but listen, I'm going through states, so maybe there is another iteration for me. So in this case 4 is 6, and 6 probably, but 6 is already in this. So next iteration. Okay, it seems I cannot find my goal state within this level. Probably I have to go to another iteration. So in this case 6, close it, open, and 6, close. And next is like you have 7, but still you see 7 is already there, 4, 2 is already there, so just say change. Okay, I'm sorry. 6, 6, for 6 I have 7. Okay, this is in the same state. 7 and 4, 1, 10. We have 10. You see 6 as the next state, 10. So change list. Next iteration. Okay, I'm sorry, I have to push it up. Next iteration. Whoa, I attained the goal state. Awesome. You see, within this iteration, plus 10. Okay, success. Woohoo! Congratulations, you provide the correct solution. Continue with the next algorithm. So cheers guys, this is solved. Second algorithm has been solved. We have another one more to go. This is Eureka. Good stuff. Okay, now let's do the next one. Now this is going to be a greedy algorithm, and in this case you can see the greedy algorithm starts with like 1, 2, 2, 4, 3, 3, 4, 4, 5, 5, 6, 1, 7, 4, 7, 7, 9, 7, 10, 0. So in this case weights are more important. So in this case the first state is 1. Putting this guy is an initial state, and you have 2, 3, 4, no, 2, 3, and 6. 2, 3, and 6. I think it's 2, 3, 6. Good. And we can change the list, and you can see for now the two asymmetric of 4. Rate is 4, and for 3 we have 3, and for 6 we have 1. In this case the 6 of 1 is slow, so push it up. And 2 has 4 and 3 has 3. Next iteration. Okay, just a minute. Okay, in this case 6, 3, 2. And next iteration 2, we have 6 in the open, so put 6 and close 6. And now if you see, we have for 6 we have the nearest node is 7, 4, 1. In this case 7 is not visited. You can put this guy But 4 is already visited. No, 4 is not visited. I think so. No. Yeah, 4 is not yet visited. In fact, yeah, 4 is not visited, and 1 is already changeless. No, wait. Okay, for 6 of 1, 7, 4, and 10. We have 10. So in this case, I'm putting 6, 7, 4, and 10. Chain list, good. And now if you see the 6, 7, now I have to sort the metrics. It's like, 10 has 0, which goes up, and this guy is back up, and we can see 7 and 4. 7 is 4, and 4 is 4. They are the same metric. So next iteration, and you can see the iteration 3 have 10, which is the goal state. So we are complete task. Great. So 10. Success! We finished the 3 tasks and 3 algorithm in 26 minutes and 8 seconds, which is, I consider, not a record, in fact, but some milestone. Well, I think people get more helpful, like helped out in the stuff, breaking their heads for 1 month or 2. I really saved their time, saved their cost. Well, I didn't mean to be greedy, but it's kind of greedy algorithm, shortest way to get your works done, And so don't save it and police. And this is going to be rocker. ng1.png. I'm just taking this for my backup. So you're done, good. And here comes the second part of this task, which is like you have to generate your own algorithm, like just generate, execute. You get the number of vertices, algorithm, goal level, average branching factor, iterations done, time lapse, and memory used is 256 bytes. Like a lot of impressive. So just take another screenshot. Oh, Brianna, wow. Don't save. Put it here. Save it as Bfs Rocky. And next, I'm going to use Dfs. Execute. See the number of vertex and the thing is like you can see here. What's that? It's like generates for your understanding, better understanding of your task. So it's like you can follow my steps. 2. Okay, next is iterative. Execute. Whoa, cool. Awesome. Great. We did it. Wow, great. Rocker. 3. Great. And finally, I'm going to do a query search, which you can come with with this number of with these values. You can come with a graph in your Excel, which is quite very good to see the performance metrics, like which one is doing good. In fact, I can use that term. But every algorithm does their job, everything has their own purpose. So Rocco. Okay, that's all for this tutorial. I hope you enjoyed this. I hope this one will be a really great, interesting stuff for you guys. And probably I will meet you with another interesting tutorial, a task tutorial, how to get it done. So have a great day and have a great weekend. So let's celebrate with Gabriel. So I can offer you a drink. So I can say Prieka. Ata.